In the previous lesson, we mentioned that the graph of a squared plus b squared equals 1 is a circle with radius 1. So this is a circle with radius 1. Now, if this circle is graphed in the rectangular coordinate system with the center at the origin of the RCS, then this circle is called the unit circle. And the point AB in the unit circle is called a circular point. Now, from this unit circle, we defined circular functions. Now, let us define the circular functions. Let x be an arbitrary real number, and let u be the unit circle with equations a squared plus b squared equals 1. Start at 0.10 and proceed counterclockwise if x is positive, as shown in the first figure, and clockwise if x is negative, as shown in the second figure, around the unit circle until an arc length of the absolute value of x has been covered. Now let point AB be the point at the terminal end of the arc. So these are the 6 trig functions or circular functions. First, y equals sine x equals b. Then y is equal to cos x equals a, and so on and so forth, where x is the independent variable and y is the dependent variable. So take note of this, guys, and see the difference of these 6 circular functions from the 6 trigonometric functions of real numbers. Actually, we can relate the two. Note that in the circular functions, in the trig functions, our sine x is equal to b over r. And since in the unit circle, r equals 1, so this one here, if we relate this one in the unit circle, this becomes sine x is equal to b over 1, which is b. So this is now what we have defined here. Same with cos x, and cos x in the trig functions of real numbers is a over r, and then in the unit circle, since r equals 1, this is a over 1 or 1 or a, sorry. And this is now our y is equal to cos x equals a. Same with the other 4 functions, the tan x, the cosecant x, the secant x, and the cotangent x. Now take note of that since this one here is AB, also this one is AB, and a is cosine x and b is sine x, we can actually replace this one as cos x sine x. Same here, which is cos x sine x. So we can relate this one to the special angles since the special angles have already values. First, for the quadrantal angles, suppose this is our circle here. For the quadrantal angles, for the 0 degrees or 360 degrees or 2 pi, this one here is 1, 0. And take note that is our AB there, and our A again is cos x and B is sine x. That's why in the 0 degrees or 2 pi or 360 degrees or the coterminals of that angle, the cosine x is 1 and the sine x is 0, as what we have discussed during the discussion on quadrantal angles. Next, for this point here, which is 0, -1, Again, that is our AB, which is cos x sine x, and meaning our cos x there is 0 and our sine x is, sorry, that is 1. That is not negative 1. Now for the other quadrantal angle, which is negative 1, 0, again, this is AB, and this AB here is cos x sine x. So in the 180 degrees, as what we have known in the previous lesson, the cosine 180 degrees is negative 1 and the sine 180 degrees is 0. Now for the fourth quadrantal angle, which is 270 degrees. So this is our point, which is 0, negative 1. Again, that is our AB. And that AB is cosine x sine x. Okay, so we can relate this to the special angle and to the circular function that cos x is 0, or cos 270 degrees is 0 and sine 270 degrees is negative 1. Now for the other special angle, which is the 60 degrees. First, what are the multiples of 60 degrees? So first, this is our 60 degrees, or that's pi over 3. This point here again is AB, and AB is cosine x sine x. And what is again cosine 60 degrees from our special angles lesson? The cosine 60 degrees here, the cosine 60 degrees is 1/2, and the sine 60 degrees is square root of 3 over 2. So therefore this is 1/2 and this is square root of 3 over 2 here, that point. Okay, and the multiples of 60 degrees, use another color here. Actually, this line here and this line here are symmetric through the positive y-axis. So this point here, which is AB, so that's cos x sine x. And what angle is that? This angle here is 120 degrees, or in terms of pi, that's 2 pi over 3. Okay, so meaning from our previous lesson, that is also 1/2 and square root of 3 over 2. Since they are symmetrical, you can just copy this ordered pair. Now the question in the second quadrant, what is the sign of cosine? It's negative. Okay, and what is the sign of sine? That's positive. Okay, next, this one here. This is our point AB, and that point AB here is cosine x sine x, and the value. But what angle is that? This one here is 240 degrees. 240 degrees, or in terms of pi, that's 4 pi over 3. And that value there is still 1/2 and square root of 3 over 2. But what is cosine in the third quadrant? It's negative. So this one here is negative. And also the sign in the third quadrant is negative. So this one here is negative square root of 3 over 2. For the fourth quadrant, okay, this is still symmetric to this one. And this angle here is 300 degrees, or in terms of pi, that's 5 pi over 3. So this point here, which is AB, that is still cosine x and sine x. Again, you can just copy this one, 1/2 and square root of 3 over 2. And then cosine in the fourth quadrant is positive, so that's 1/2, and sine in the fourth quadrant is negative. Next is for 45 degrees. For the 45 degrees, we have these angles. This is 45 or pi over 4. This is another 45. That's 3 pi over 4. Take note guys, the quadrantal angles are also multiples of 45 degrees. Then this one here is 5 pi over 4, and the other one here is 7 pi over 4. Okay, you can actually convert that one to degrees. So our point there, the points are again AB, which is cosine x, sine x, and cosine 45 degrees from our previous lesson. The cosine 45 degrees is square root of 2 over 2, same with sine. So this one here is square root of 2 over 2. This is also square root of 2 over 2. So therefore this one here, this point here, which is AB, is cosine x, sine x. That is also square root of 2 over 2, square root of 2 over 2. But the sign of sine in the second quadrant is negative, so this is negative. Same here, that's square root of 2 over 2, square root of 2 over 2, and both signs are negative since cosine and sine functions are negative in the third quadrant. Here, that is also square root of 2 over 2, square root of 2 over 2. Correction, in the second quadrant, the sine is positive, the cosine is the one that is negative. So this is negative. Okay, now for the fourth quadrant, cosine is positive and the sine is negative. Now you can do the same thing for the 30 degrees. Just get the multiples of 30 degrees. What are the multiples of 30 degrees? Of course, the quadrantal angles are multiples of 30 degrees. And aside from that, we have 30 degrees, which is pi over 6. And then 60 degrees, that's also a multiple of 30 degrees, and that is pi over 3. Then we have the 90 degrees, which is the quadrantal angle, pi over 2. Then we also have 120 degrees, and 120 degrees is 2 pi over 3, and so on. Okay, you can complete the table, you can complete the circular functions, and then the point AB.